Welcome to another explainer. Today, we're taking what usually looks like a super dry list of network protocols and turning it into the actual story of how machines talk to each other. If you've ever wondered how just a few lines of Python can connect systems across the globe, you are absolutely in the right place.
So, let's just dive right in with a pretty foundational question. How exactly do we teach machines to communicate? Well, we're going to look at how Python acts as a sort of universal translator. You know, it's one thing to write a script that runs locally on your laptop, right? But the real magic happens when that program reaches out across the internet to fetch data, send messages, or stream a video seamlessly to the other side of the world.
Here's our roadmap for today. We're taking a building blocks approach. We'll quickly cover how computers actually communicate, dive into the engine room with sockets, speak the web with HTTP, look at real-time and async magic, cover security and handling errors, and then finally wrap up by building the real world. Simple, structured, so we don't get lost in the jargon. Let's go.
Okay, Section 1. How computers actually communicate. Let's look at the fundamental rules of the digital road before we even think about writing any Python code.
Whenever devices talk, whether your browser is loading a site or an ATM is pinging a bank, they rely on three main concepts. Think of the IP address as the physical street address of a massive apartment building. But, just getting to the building isn't enough. You gotta know which door to knock on. That's the port number, the specific apartment where a service actually lives, like port 80 for HTTP. And finally, the protocol. That's basically the rules of the mail service delivering your data. Do they need a signature, or do they just drop the package at the door? These three things have to work in perfect harmony for even a single packet of data to reach its destination.
And this creates an invisible handshake that's literally happening millions of times a second. In a standard client-server setup, the client, like your web browser, knocks on the door to initiate a connection. The network routing then connects you to the target server. The server gets your request, processes it, and shoots the right data back. It's just this constant, incredibly fast loop of asking and answering that forms the entire backbone of everything we do online.
Moving on to Section 2, Sockets, the engine room. Let's look at the actual vehicles carrying all this data.
So the crucial piece of this whole puzzle is the socket. Simply put, a socket is an endpoint for communication between two machines. If you want to connect two computers, you create a socket on both ends and essentially string a digital wire between them. And the cool thing is, Python uses its wildly powerful built-in socket module as the main entry point to make this happen, giving you low-level access right to the hardware network interface.
Now here's where it gets interesting. We've got a face-off between the two main types of socket communication, TCP and UDP. TCP is like sending certified mail. It's connection-oriented, guarantees your data arrives in perfect order, and confirms delivery. It's slightly slower, but absolutely vital for things like banking apps and APIs where a dropped packet is a big deal. UDP, on the other hand, that's like throwing a postcard out the window of a moving car and just hoping it lands in the right mailbox. There's no connection setup, no delivery guarantee, but man, it is incredibly fast. That's why it's the undisputed king of multiplayer gaming and live video streaming. You care way more about speed there than a dropped frame.
All right, Section 3, Speaking the Web with HTTP. We've got our engine room built, so let's move up to the language most of the modern web actually speaks.
While sockets are those low-level wires, HTTP is the high-level language apps use to talk over those wires. Most modern applications use HTTP, relying heavily on four foundational methods. You've got GET to fetch data, POST to create it, PUT to update it, and DELETE to remove it. And by using Python's awesome requests library, you don't even have to build complex sockets by hand. You can easily command these four methods to interact with almost any modern API on the planet using just a couple lines of code.
Next up, Section 4, Real-time and Async Magic. Standard requests are great, but how does Python handle the massive real-time demands of the internet today?
The answer here is asynchronous networking and WebSockets. Normally, code runs one line at a time, right? It blocks the program while waiting for a network response. But Python's asynchronous module lets your program juggle thousands of network connections all at once without waiting. Throw WebSockets into the mix, which keep a two-way, real-time connection open indefinitely, and suddenly you have some serious power. This constant, open stream of data is exactly why your Netflix doesn't buffer forever. It's how live stock trading systems process millions of orders a second, and how your multiplayer games stay perfectly in sync. It is literally the lifeblood of the instantaneous web.
Section 5. Security and handling errors. Because building an amazing, fast digital city means absolutely nothing if the walls aren't secure and the roads are full of potholes.
Let's be real.
Out in the wild, networks break. It's just a fact of life. You're going to hit common errors like connection refused when a server just isn't running, timeouts from a sluggish network, broken pipes when a connection drops mid-sentence, and DNS errors when a hostname can't be found. These are the hurdles you'll inevitably face. That's exactly why handling exceptions elegantly in your Python code is a non-negotiable part of network programming. I mean, your app really shouldn't crash just because the Wi-Fi blinked, right?
And beyond just errors, you have active threats. You have to build securely from day one. Always prefer encryption by using SSL and TLS so your data isn't exposed in transit. Make sure to validate users through strict authentication methods like JWT, OAuth, or API keys, and rely on firewalls to protect that network perimeter. Because out in the real world, production systems are constantly being probed and attacked. You've got to lock the doors. Finally, Section 6, Building the Real World. Let's pull all these building blocks together and see how they construct the digital world we use every single day.
So how does this all translate to reality? Well, the underlying network structures we've been talking about are powering the apps sitting on your phone right now. WhatsApp uses real-time WebSockets and asynchronous messaging to deliver texts instantly. Your banking app relies heavily on secure, encrypted TCP connections to guarantee every single cent is accounted for. And Netflix, they utilize UDP and highly optimized protocols to stream massive chunks of data straight to your TV. These core theories are the beating heart of modern consumer tech.
And the beauty of it is that Python gives you the perfect scaffolding to build these applications yourself, so you're not reinventing the wheel. You can grab frameworks like Flask to spin up quick web APIs, Django for massive secure enterprise apps, FastAPI for incredible async-driven performance, or Twisted for super advanced low-level networking. Python basically hands you the exact tool you need for whatever scope you're tackling, abstracting away the really hard stuff so you can just focus on building.
To wrap up our technical journey, here are 5 rapid-fire, absolute best practices for any backend or full-stack developer. 1. Use exception handling, so an unpredictable network doesn't completely crash your app. 2. Always close your sockets properly, so you don't bleed vital system resources. 3. Encrypt your data. User privacy can never be compromised in transit. 4. Validate every piece of input to stop malicious code right at the front door. And 5. Use threading or async architecture so your app can effortlessly scale to handle thousands of users at once.
We've covered a massive amount of ground today. Now that you understand how to wire the digital world together, from basic sockets all the way to real-time WebSockets and secure high-performance frameworks, the immense power of the internet is practically at your fingertips. By combining tools like Python, FastAPI, WebSockets, and asyncio, there's literally nothing you can't create. So the next time you stream a movie or send a real-time message, ask yourself, what invisible protocols are silently shaking hands behind the scenes, and how could you harness them next? Thanks for joining me on this explainer, and I'll catch you in the next one.